Alrighty, here we go. This first section just had an awful lot in it, and I want to make sure we're very, very confident and clear on some of these algebraic skills before we dive into complicated equation solving. So that's why we are splitting section 1 up into 2 parts. So yesterday, you focused on simplifying algebraic expressions. Today, we're going to focus on one property called the distributive property. All right. So make sure you have the heading 11, chapter 11, section 1b in your notes, distributive property. Here's learning target for today. By the end of today, you will be able to simplify algebraic expressions by using this thing called the distributive property. Okay. All right. If I asked you to do this and I said, oh, no paper, no pencil, no calculator, you have to do this in your head. Okay. Now, what some people do, and this is kind of where we had to start thinking of it this way, and doing the multiplication like this, and then you got to carry the 1 and blah, 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 blah. Or if you're old like me, we didn't have handheld calculators around when I was learning math, especially in junior high. It wasn't until later. Here's how we think about it and break it apart. 82, I think of as 80 plus 2. And I have to multiply both of these by 7. I have to take 7 times the 80, so that's 560. I'm keeping that in my head. And then I'm thinking 7 times 2 is 14. And when I add them together, boom, there you go, 574. Okay. What if I said, what's 12 times 99 cents? Ugh. All right, if you literally started doing it this way, this is ugly. Okay, you got to make 2 rows, then you have to add them up. You have a bunch of carrying and carryover, and it's just a lot of computation. Or you could think of it this way. 99 cents is just 1 penny less than $1. Okay? And frankly, this is going to be a lot easier for me to do because I'm going to say, oh, 12 times $1 is 12 bucks. And then I'm going to subtract away 12 times a penny, which is 12 cents. There we go. And now I can think of doing that in my head. I'm saying, oh, well, take away 12 cents from 12 bucks. That'll leave me with $11.88. Boom. And to me, that's a whole lot easier than doing it this way. This property that you're using, where you have more than one term in the parentheses and then you start multiplying it through, is called the distributive property. Okay, so what you're doing is you are utilizing this process where you are multiplying something that's outside the parentheses through every term that's in the parentheses. And the reason I have the angry bird thing up there is because the way you're going to keep track of things is by drawing little arrows to make sure you've distributed to everything inside the parentheses, which kind of looks like when you start flinging things in Angry Birds, you get those little arches, and there you go. So let's look at some of these. The reason really that it becomes so incredibly important is because when I look at this algebraic expression where it says 5 and then times, and then it says x minus 4 in parentheses, 5 times this quantity, I can't combine x and 4 into one term because they're not like terms. So I'm either going to just say I have to leave this as is, or I can use the distributive property. I can take 5 times 1x. That's going to give me 5x. And I can take 5 times this minus 4. That is going to give me minus 20. Now, I've gotten rid of the parentheses. I did what I call distributed this multiplying by 5 through each term, and now the parentheses are gone. Yes, I can't combine 5x and 20 because they don't have the same variable. Okay, this has no variable. This is constant. So done. That's all you got to do. Oh, what if I had negative 5? That's all right. You'd take negative 5 times the x, and then you have to take negative 5 times this minus 4. Okay, now this becomes a little tricky. How should I write this? Because I've been telling you, think of this as negative 4 instead of just minus 4. So think of it as going negative 5 times negative 4. And you should end up with this. The first term's easy because that was just a 1x, so you get negative 5x. This actually becomes a positive 20 or plus 20. This is how I think of it. I think of it as negative 4. If you're more comfortable thinking of it this way, I'm taking negative 5 times the x, and then I'm going to subtract negative 5 times 4, and I'm calling it 4 because I brought this and treated it as a subtraction symbol. Then you get negative 5x minus negative 20, which, subtracting a negative simply becomes adding the opposite, adding the positive. Whichever way works for you, that's the one I want you to use. Okay, let's look at another one. Whoa, look at this. True, sometimes the number you multiply by is going to be behind the parentheses. That's okay. We're still going to distribute. You just simply take your little arrows and go this way. So the first thing you're going to do is take 3 times 2m. 3 times 2 is 6, and then times the m, 6m. Then 3 times this minus 7, or negative 7, gives you negative or minus 21. Can't go any further because this has a variable and that does not. Let's look at this one. Okay, it's up in front again. Negative 7 times this whole quantity, x minus 5. I'm going to get negative 7 times the x. Then I get negative 7 times this minus 5, which is positive 35. Done. Oh, look at all this negativity. Ooh, here we go. This time, this negative 3 is in the back. Okay, sometimes they'll write and put extra parentheses around here so you don't see times minus right in a row like that. Times negative 3. All right, we're shooting from behind here. Negative 3 times negative 4y. Negative 3 times negative 4 times y. Okay, gives me positive 12y. Then I have to take negative 3 times this minus 3. And negative 3 times another negative 3 is positive 9. Done. Cool. What about this one? This one's a little tricky. Let's take a look here. There's just a minus sign out front there. However, there's really a number. It's not written down, but it's really a 1. I need you to think of this as negative 1. And this time, looky here, you've got 3 terms to distribute to. Negative 1 times a positive 2m. Negative 1 times plus 6y. Negative times positive, negative 6y. Negative 1 times a minus 5 is a plus 5. Done. Notice what it did. It basically just flip-flopped every sign for each term. All right, now you're going to do a bunch of work with the distributive property, and then you're going to have some more simplifying to do on some of your problems today. So when I look at this, I see 5 times the quantity, x minus 4, so I'm going to distribute 5 times x, 5 times that minus 4. Now my parentheses are gone, and I have this 2x that comes down to join the party. Now look for like terms. Do any continuous simplification if you can, and this gives me 7x, and the 20 has to stay as is, 7x minus 20. Look at this one, okay? Simplify the expression, first distribute. 30, a 6n. Now my parentheses are gone because I've distributed, and then I have a minus 2n here. Combine these like terms together, that gives me a positive 4n. And 30 just comes on down because it's a constant and has no other like terms with which to simplify or combine. All right, let's distribute this guy. 3 times the c plus 3 times that positive 7. And then there's this minus c at the end. First things first, remember that that's a 1. Combine your like terms, and always, you and me, baby, we're stuck like glue. Keep that negative sign with that 1c. That gives me 2 c's. And then I have a 21. That's it. Oh, look at this one. All right, first distribute the 6. 6x plus 30. Bring down the plus 3x. Hold your horses. This is a negative 1, which has to be distributed as well. So this is a negative 4x. Negative 1 times a minus 1 is a plus 1. Let's combine x terms. There's 3 of them. A 6x, a plus 3x, a minus 4x. That leaves you with 5 x's. Then I have a plus 30 and a plus 1. A plus 30 and a plus 1 is plus 31. Done. Ta-da! All right. Let's just jump into the worksheet, shall we? There's a couple challenge ones on the back, so be super duper careful. All right. All right. Distributive property, tons of fun. Just think of Angry Birds. And as always, may the force be with you.